So hello everyone, my name is Anurag and I am here to present a small demo of the project that I have been working on for the past 6 weeks. So basically it is a system for insider trading detection, and I'll quickly summarize the problem statement here. So BFSI compliance teams have to catch insider trading signals hidden inside everyday employee communications, be it through messages or chats or emails. So a human can't read everything, and a black box AI system can't be depended on for the decisions which may have regulatory consequences. So I have built a system which has both an event-driven pipeline that evaluates every message automatically, and a human-in-the-loop review layer that has the actual final say. So I'll start with the demo. As you can see, this is the Slack channel where I am getting alerts. So So this is a script that I've prepared, which gives us all the relevant logs. Obviously, I have the Docker up and running, so we have all the logs here. I've prepared this script only for the relevant logs. So we can see the last logs are being shared on at 16:37, right? So we'll quickly send an email. So this is an email that I have prepared, and as you can see, I've written here you can pick up some shares. So this has high possibility of being triggered as a as an attempt for insider trading. So I'll quickly send the email, and you can see the last logs are being triggered at 16:37. And as soon as I send the email, I'll change it to 25 and 13, right? And as soon as I send the email, we will be able to see the logs here for uh, all the execution of the system. Right, yeah. So these are the logs for the execution here. It started from 17:05 and went on, started with the producer cubed Kafka event, and then we can see completed LLM evaluation, creating compliance decision created, then execution of the compliance action, and we have the review case created here, right? So quickly show you the architecture here. So I've basically created two paths for ingestion here. One of them being the API called /ingest using FastAPI, and second one being the Gmail IMAP listener, which we basically use at the in the initial stages of this demo. So all the events which are being shared through this two ingestion pathways, those are being stored in the raw events topic, and on those events we have the consumer normalization as well as the uh, retrieval for the relevant policies from the fast vector index, and all of this is being blended with rule engine, and then all these processed events are then sent ahead. All the events which meet the failure are being stored in the raw events dead letter queue. Now, all these processed events are then sent forward to the compliance consumer LangGraph workflow, which has multi-provider LLM gateway, and the events which pass through and give us the compliance results then are sent to the result consumer. Now here the results are stored in the SQLite database, and the auditing is done. Audit logs are being stored in the JSON file as of now, right? And on top of this SQLite database, we have created a Streamlit dashboard which has review queue, assignment of the reviews, as well as the SLA, bulk actions, and exports. All of these features are implemented in the Streamlit dashboard, and we also have the review REST API, right? So we will quickly take a look at the system here. So right now, let me just rerun the system. Now we have this complete overview of the dashboard. Alerts by policy label, review queue status, rejected, pending, escalated, approved, risk score distribution. Now we'll go in the review queue section. So this is the recent event or the email that we have sent. It has high risk score around 0.94 here. You also have the SLA breach checkbox also for how many hours it has been open. It is being opened. It is still being opened. And now if we copy this review ID and paste it here to give the details, we'll get a complete overview being stored as a JSON in JSON format. So all of this is being done through using Pydantic framework, and we can also download the regulatory report here, and it has all the sections like case identification, its review ID, event ID, decision ID, its status is pending, right? So here also we have the event details here, and of the event details we have the complete email here, we have the risk assessment score, priority level, then violation label, everything is here, right? So this is the review details. Now if we are to assign this to someone, right, we have to assign it, right? So here it is not being assigned to anyone. We will assign it to someone. I'll assign it to me as of now, and we can see it is being changed to us. Assigned to column has Anurag.Tale here, right? Now we can select, right, it is pending and email, right? Now we have to take some action on this review ID, right? Now we'll choose that ID and we can state that it is clear indication of insider trading. Okay. Now the last alert that we received on our Slack channel was on 10:14 and it is 10:41 now. So as soon as I approve or escalate or any action I take, so because this has a high risk score, I'll approve this one, and as soon as I approve, it moves out from this queue, and we can see it is being approved, source type being email, and we have got a new alert here, right, which has a high risk score. Okay, so this is a complete end-to-end execution of this demo. So I have also implemented the role-based access controls here. Currently we are logged in as admin. So in the admin I have the LLM gateways being implemented. We have the LLM gateway panel here. Here we can see the latency, the cache hits, the provider which is being used. So here I've implemented bring your own key concept, and we can implement, or like we can add 2-3 more providers here. I have implemented it for Grok, Gemini and OpenAI, and currently I'm just using Grok. So this is the one we are able to view here. We can, like, for recent request, each and every request we can see the trace ID, the event ID, as well as the latency, whether it has hit the cache, any error that we were facing, right? So this is the complete system. We are logged in as admin. We can also log in as reviewer. I'll quickly paste the password here. So now as you can see, there is no LLM gateway dashboard here for a reviewer, right? So this is the project now, and obviously this is not production ready yet. It has some limitations, and I'll quickly go through the limitations that I have documented here. As I stated earlier, that SQLite is the system of record as of now. It is fine for demo. But a single writer database is not a serious answer for a system meant to process a continuous event stream at real volume. Uh, as of now, we just have implemented one Gmail account, but when there are many accounts and there is a continuous event stream at real volume, when we have more users, then SQLite may not be the correct answer to our issue. So we may have to go for some other databases like Postgres uh, or any other, right? The second limitation is ingestion is Gmail only, and real BFSI regulated communications happen on Bloomberg Chat, Symphony, MS Teams, and maybe Slack also. So none of this is being implemented as of now. We just have the Slack being implemented. So this is the single biggest gap between demo and a useful system for a compliance team. Then we have no user management UI. Login is like pretty straightforward. We have the passwords and the usernames as of now, and the users are not like allowed to generate new passwords and all as of now. But again, this is one of the limitation. Then we have narrative content reaches a third-party LLM API. So I have taken care of this masking of personal information, and we have implemented structured PI redactment, but the amounts or the figures which are being sent in the email, those are like straightforward sent to the LLM, which is an issue because it is a confidential information. So a stronger answer here would be a self-hosted model, and for big companies it is a real possibility, they can do that. And the final limitation is no measured accuracy. Detection has only been exercised against handwritten demo content, not a real labeled dataset. So again, we can do the labeled dataset here and improve the accuracy. But yeah, in this system there is no known false positive, false negative rate. So this is the GitHub repo that I've created, and you can obviously make use of it, the complete, if you want to go through the complete project. So this is the complete project here, and basically this project was really about the engineering patterns underneath Kafka's delivery guarantees, LangGraph's state-driven orchestration, human in the loop as an actual state machine, and treating LLM reliability as a systems problem, not just a prompt. So I have linked the GitHub repo in the description, and you can go and take a look at the complete project. And yeah, that's it. Thank you.